All right. How we doing?
Good.
Week 8. Almost done. Almost done. Those of you that had me for 2 terms, saints. You had me for 3. Chris, you had me for 3.
Dude, like
Merit badge.
I took 1 and 5 twice.
Oh, you did?
I remember that.
Jesus,
too.
you remember that?
Yes.
It's terrible. You're same jokes for 4 straight terms. Terrible.
Right.
So, what I want to do today is, we're almost done. I mean, as far as what we need to do in this class. You guys got through the lion's share. The beautiful part about 244, kind of compared to 243, is once you understand how a hypothesis test runs, they all run that way. It's just a matter of knowing what to do with the data that you get. You know, what adapter do you have to plug it into, like we were doing today with the, you know, which do I use the RCA plugs, do I use the 1/8 inch, do I use this amp? It's all a matter of, it's all sound. It's all sound going into a cable. The trick is which cable do you have to use to get the sound to come out the other side in a meaningful way. And hypothesis testing is exactly the same. I mean, there's no difference. It always ends with a test statistic and a p-value, and a conclusion based off of that p-value. And they always start with hypotheses. That's the only, those are the constants. The only variable is what you do to the data you get. And that's why I kind of tortured you guys last time with that Excel spreadsheet and the walkthrough of the break example, is because I wanted you to think, how would you deal with data like this? And we'll do a little more of that today, especially with the iPod, because the iPod brings a whole new question to deal with. But we're getting close to the end of the type of data I'll torture you with in this class. If you need more, you've already seen somewhat more. When you guys ran that out of class, non-parametric, where you're holding down F9 on Excel, did that look, by the time that was done, did it look familiar to you? Did the graph that popped up look familiar to you? I tried to color code it to kind of make it jump. Did it look familiar? You saw what kind of a graph? A normal distribution, a bell curve, perfect, Rosie, thank you. And it was beautiful, it belled itself out nicely. Did you catch the part about the non-parametric? I didn't have to go in saying, assume it's bell-shaped. It just ended up being bell-shaped. That's the best part. Why assume something's going to happen if you can observe it happening? Yay. And then, what was happening with the little yellow chunks that were popping up? Those little yellow, the curve was mostly red, yes? And then little yellow ones would pop up every once in a while. What was up with the yellow ones that popped up every once in a while? Do you remember? I'm asking you to go back 2 days now, and I apologize for that. Ryan's like, that's flush, dude. That's going on hand and I forget about it.
Weren't they the unusually low?
Yes! Thank you, Cassie! That was the unusually low bit, because the whole point of that problem was to realize the epileptic patients that were claiming the seizures were happening with more regularity, what was actually happening?
Lower.
They were happening with lower regularity. At least it looked that way based off the one test statistic. So you guys built a distribution around that, and you saw how infrequently you would see that few seizures, assuming that they're operating at 25% frequency. So you actually concluded that they're happening with less than 25%, which is exactly the opposite was being claimed. Freaking rad. Totally rad. So that's the beauty of a non-parametric approach. You did the exact same thing with BP. Just now, you just turned it in. If anybody else is as upset by the amount of oil as I was, maybe not. Maybe you were. Maybe you were. I remember doing the math the first time and being totally stoked that we could do that, and then totally nauseated that it actually happened. So kind of on both sides of the coin there. Someone also told me once that at least that much oil leaks out of the earth every year naturally. If you look at all the fissures in the bottom of the ocean that just leak natural petroleum products, they say at least that much oil every year leaks out on its own. I was like, yeah, I totally believe that. Much in the same way, if you pee in a pool, don't recommend doing this, the chlorine can take care of it. Or pee in the ocean for that matter. I remember Max being so upset in Aruba, he's like, Daddy, I gotta pee. I'm like, dude, pee. And he was like, I could see him so conflicted by that. Like, but I have to go potty. I'm like, pee. And then he's like, but, I'm like, where do you think fish go? And he's like, oh, psst. And then it was fine. Because there's a natural filtration system that deals with that kind of stuff. Even the occasional human that pees in the ocean. My problem with BP is that it all happened in one place. That's different than the entire ocean leaking oil for, an entire year's worth of time. This is all that oil in one place in 86 days. That was my issue. So that argument, in my opinion, doesn't hold statistical merit because it's apples oranges at that point. Actually, it's apples and a really, really big freaking oily orange. So, anyway. But you have statistics to deal with it. But nothing like that exists in most textbooks. Isn't that a shame? I had to use that method for, my cousin Kara was doing, she was working in geriatric rehabilitation of muscles. So like 80, 90-year-old people that had had injuries and had to rebuild their muscles. They had atrophied horribly from even like 6 months of not using them. It's amazing what happens as our bodies age. And she had a sample size of 3. And she did an ABA study where she had people and she strength tested them at the beginning, 3 people, three elderly folks. Then she gave them this it was a warm water therapy. She'd immerse them in this like warm water bath and then have them do all kinds of flexibility exercises. And then she tested their strength after 6 weeks of that that regimen, and then stop it and then test them again. And what she noticed in these 3 was strength went up and then strength fell back down again when she removed the therapy. And she's like, this is great, except I've got 3. What do I do with this? I said, just a ticket. We did one of these. We did a bootstrap on it. We just said, I said, do you think you have good data? She's like, I'm almost positive I do. That's the key. It's always the key. Do you have good data? If you have good data, you can do something with it. Just like I have 6 data points here. That was woeful. Yes? Woeful, but that's all I had. And yet we got as good an estimate, if not better, than the Coast Guard. Hell yeah! Did you guys feel like a little... Remember that? I did. It's like, screw you, Coast Guard. We can do it the right way. No, I'm just kidding. I'm not saying screw you, Coast Guard. Screw you, Coast Guard math. There we go. That's better. We did better math than them with 6 data points. It's amazing. But this is the problem. People speak with authority on numbers they don't understand. It's about 1,000 barrels a day. Where'd that number come from besides your butt? It came out of thin air. That's the problem. You can't be throwing numbers like that around unless you've measured them. And this is a statistical lesson. It's also a life lesson. Don't believe everything you read on Facebook. Don't believe everything emailed to you. And I know this sounds stupid to say that, but how many arguments precipitate with, well, I heard once that. Guess where they heard that? Their mom emailed them a mass email about the latest scam, or this, that, or this, that. Back check, fact check. Figure where the data came. If the data is useless, then the figure is useless. Yeah? Okay, soapbox off. So, let's chit-chat. We were in the middle last time. I want to do one more of these to make sure you know how to run this particular test. We're in the middle of doing two parameter hypothesis testing. 2-parameter hypothesis testing. And I am going to do my damnedest this weekend, if not tonight. I think I got the idea that you guys like the templated approach to the hypothesis test, like I did it on the exam, where I have you guys fill the hypotheses in, you put the test statistic, put the p-value, circle the correct conclusion, circle the types of error, and that kind of stuff. I think I get the feeling that you guys like that template better than the one that's in the textbook. Is that a correct feeling, or is that just what I have for breakfast? Do we like the exam template? You also did on your take-home I just gave back to you, that first one that you filled in, the grade-in boxes, where I put H0, H1, and you fill it in. Is that decent? Is that a good way to finish the course out? I'm going to do my damnedest then to get in the textbook and create a template like that for every single problem that I have left for you to do to practice. And I'll have all the quizzes with that same template idea. I just got to find time between now and Monday, I guess, to do it. But I will. It's my God-bedding coffee. But anyway, if that's helping you learn, if that template is helping you learn, then we keep doing it. So, yes, it's good. It's good. Yes, it's good. Okay, good. Very good. All right, 2-parameter hypothesis testing. There's 2 different parameters we're testing. We're testing an average, and we're testing a little proportion. That's little p. Let me make it little. Little p. Now, both of those generate a big p value. Both of them generate a big p probability value, which is the same letter but a totally different meaning. The difference now with 2-parameter hypothesis testing is there isn't just a mu. There's 2 of them. And there isn't just one little p. There are 2 of them. And this is what we wrestled with last time with a couple examples. One was my cantilever brakes versus my linear pull brakes. Both of those brakes had an average stopping distance. Cantilevers, linear pulls. We couldn't match them up, we couldn't subtract them and look for a difference because the data didn't work that way. So you actually have to deal with 2 averages independently. That's kind of important. Much the same way, we haven't looked at these yet, we'll look at some of these today before we get into the iPod example. But you're going to have 2 different percentage rates that are not the same. Like on your last exam, you looked at the H1N1 virus and the vaccination rate isn't working. Well, that's because you're comparing it to one number, 70%. What if you have 2 different vaccines that you're testing and seeing which one is better? Well then, you may have to have 2 different percentages that are independent of each other. So the big word here is independence. These populations are independent of each other. They're not connected in any way. They're totally independent of each other. And we deal with that. We deal with that. For starters today, let's look at one more example of means, then we'll get a couple examples of proportions. It goes pretty quickly. There's not much to it once you understand the basic globe by globe. Take a look at your data sheet on page 2. I was interested in this one only because I teach math, and math curricula in America keep changing, which I think is a fantastic idea. because the way we taught math 50 years ago is not the way math should be taught right now. So every once in a while, you'll see a new curriculum come out, and then they try to decide if that new curriculum is better for students to learn mathematics. And statistics is no different, except, well, it's different in the topic, but it's not different in the fact that I'm constantly tweaking things to try to make you guys learn better. So take a few moments right now, friends. Take a few moments right now and look at... I don't know. I might. Oh, I have one more. Bottom of page 2, it says 2 independent means testing, Core Plus Mathematics. Take a few moments, check that out, see if you can get anything from it.